Hey folks, I'm here to talk to you about the new Drillhole planning module, which has recently been added to Studio RM version 1.5. Now, the Drillhole planning module is currently designed for a wide range of use case scenarios, which means that it has a lot of functions and a lot of buttons, and it can be a bit daunting when you first open it up. So to help with that, I'm going to be walking through a few different scenarios with the tool so that you can begin to get a better feel for essentially what each button does and the purpose of each function. Now, we're going to start with grid drilling. This scenario would be for things like exploration drilling, where you're designing from a surface topography to a projected target, or perhaps in-pit grade control drilling. As a starting point, we're going to need two wireframes, as you can see here on the screen. Just FYI, the target can be either a surface or a closed volume. I'm just going to go ahead and open my drill hole planner. This can be found under the sample analysis tab and on the far left drill hole planner. Okay. I'm just going to get things going. So I'll scroll down to my target picking and tell the tool that I want to be targeting my target wireframe. And I'll just choose exits as I want to go through my target, which in this case is quite narrow. I'm going to choose my first color manually. So I'm going to hit color and then right click on the surface and add new hole. And there it is. You can see that it's snapping to the surface, the target, and it's currently dipping at 90 degrees. Now, I want to add a bit of over drill to that because we never just want to drill to our target, do we? So I'm just going to give that maybe 20 meters. That should do it. While I'm playing with the first hole, I'm also going to give it a dip and a dip direction, just maybe a bit of an adjustment to get a more ideal intercept angle. So you can see I can adjust these either on the fly just by pressing the up and down button, or I can just manually type them in and adjust the drill hole. Now let's generate the grid. Just go up to the add new hole section and let it know that we want our collar snapping to our surface topography. And as we generate new drill holes, let's go for 25 meters of spacing. And as I click add new holes, you can see that they're beginning to be generated. Snap to the surface topo, the target, plus 20 meters. There we are. I'm just going to continue to generate the grid. Take a left turn, and back along my grid. And a right turn, and back along again. You can see how this is a fast and easy way of generating your drill hole program. There are a few other cool things I can do at this stage, like drill hole deviation and generating intercept tables, but let's come back to that. Let's talk about the module's use in drilling from a single collar point to multiple targets. First, we're going to pull up our subvertical target, and we'll use one of our DTM functions called grid DTM to generate a target pattern. If you don't already know about grid DTM, it can be found under structure, and if you go to DTMs, drop down, you can find grid DTM. Okay, so here we choose the name of the points object that we're generating, the wireframe object we're generating it for, the orientation on which the grid spacing is based on, and the grid spacing. So I'm just going to go ahead and choose 75 by 75 meter spacing. And you should be able to see these red target dots, which have now been generated along the surface of our target wireframe, basically making for perfect targeting points. We're going to open up the drill hole planning module again. And I'm just going to, just a moment, manually choose our collar point, just like we did with the grid pattern. Now for the target. Now, rather than choose a target wireframe, as we did before, I'm going to snap to our generated grid point. So just going to right click here, and there's my target. Just like before, I'm going to add some over drill just to make sure we actually intercept the ore body. Let's have a look. And let's give it 5. Nah, let's crank it up to maybe 20 meters meters of over drill. There we are. Once I'm happy with that, I can go ahead and create another hole, snap to the target, create another hole, snap to the target, just like so. Now with this row above, I'm just again ensuring that I've got a suitable over drill. I'm actually sure that I'm going to hit my target. There we go. Now, according to the clock in the little bottom right hand of my screen, that's about 4 minutes to put together a nicely gridded drill program with correct over drill to actually hit our target. So that is not too bad at all by my counting. Okay, so next, let's talk about some of our deviation tools. So let's say we've drilled a couple of holes from this program, but they are deviating. So what do? That brings us to one of our new query tools, query multiple drill holes. Okay, so here are the two drill holes that we first drilled. Let's actually have a read of them. So go up to query, drop down, and hit that static drill holes button. So you can see that this query outputs a fair bit of information. It gives you the drill hole IDs, total length of the drill holes selected, and for our purposes, the drift of the drill holes. So the average drift of these two drill holes was negative, basically 8.79 degrees per 100 meters. So now that we know that, let's apply that information. So we'll pull up our drill hole planner. I could have used the program that we designed just before. However, just for the sake of repetition, I'll just use this information to show you how to create deviating drill holes. Okay, so once again, I want to pick my collar. So I want to right click to snap to my collar point. And once again, I want to snap to my target point. All right, and add a new hole. There it is. So now we'll add that over drill as we did before. Now, if we go down to deviation, we actually have the ability to input deviation of that drill hole. So negative 8.79 degrees, and there we are. So what I quite like about this is that you actually select the target, so you keep your target the same, but in this case, when you add in your deviation, it will back calculate essentially the necessary azimuth and dip at your collar point in order to still hit that target that you're trying to hit. So that's quite, well, for me, that's pretty cool. So let's get our first look at save to tables. I like to joke that it's sort of a DD survey method, but nobody seems to think that's funny. But it does break down your drill hole file into its constituent parts. So it's collar, it's survey, and it's samples. So let's just open up that collar CSV that it's created. And there we are. We can see for those three drill holes that we've just created, these are the new azimuth and dips that the drillers will need to collar on to cope with that deviation. So that's drill hole deviation. Now let's just crank things up a notch, and I'll show you how to flag our drill holes with a loaded block model. If you already got like a resource block model which you can use, that's great. If not, let's just quickly generate something for ourselves. Okay, we're going to use a sort of quick and dirty process for generating block models called wirefill. All it requires as an input is our wireframe file. There's no need for a proto, and in this case, we really just need to specify our output. And because you can see in the background there, I've now got two stacked wireframes, I want a differentiator. So the column where I'm differentiating these is called load. All right, so hit OK, and that will generate for us a quick block model inside of the wireframes, which have been tagged with, in this case, loads 1 and 2. I'll just load that in and display it as blocks so that you can see that. There we are. And there you can see blocks with the tag load1 or load2. Okay, so to flag our drill holes with this information, I simply have to, in the drill hole planner, select the block model up here and hit apply all. There we are. So I'm just displaying my drill hole file based off that load column. And now you can see in my drill hole file, I've actually tagged it with load 1 and 2 from that source block model file, which we've just quickly created. So obviously this is great for expected intercepts of different loads or even shear zones, that kind of thing. But you can also go so far as to perhaps populate the drill holes with your resource block model grades and then do comparisons of your expected intercept grades versus what you end up with once you've drilled the program. Now that we've flagged our drill hole files, let's talk about an easy way of creating intersection tables with those. Okay, so I'm just going to go ahead and save my drill hole file because I'm going to be running a process on it, so I need it as a saved file. And I'm just going to do sample analysis and compositing. So I'll use my drill hole file as the input. I'll make just a comp output. And in this case, I want to make sure that we're compositing over that zone field. So it'll pay attention to that zone field as a composite boundary. And I'll just make my interval something ridiculous, like 9999, and my min gap 1. There we are. Just going to drag that in and make sure I have that selected in my drill hole planner. Okay. So now when I go to use save to tables as my export, it should be composited around basically those load tags. I'll just open all 3 of these CSVs at once. There we go. And I'll just grab the sample one. And if I just filter out basically everything that isn't interesting in terms of load structures, there we are. I have a drill hole intercept table with the expected intercept depths for both my loads that I can provide to the core yard or the drillers or that sort of thing. In addition to drill hole intercept depths, you could tag your drill holes with, for instance, gold grades, RQD information, or well, frankly anything that you might have estimated into your block model. So that's quite a bit to squeeze into a single tutorial about one new function. We covered grid drilling, fan drilling, query multiple drill holes, how to flag our drill holes with a block model, as well as generating intersection tables. Thanks very much for listening. And yeah, if you did find this helpful, do please let us know. Thanks very much.